can be seen on line 28 in glibc 2.3.6 stdlib rand.c file, or alternatively man3 rand on a Linux box should work too. By default, the implementation uses a linear feedback shift register with 128 bytes of state information to generate random integers ranging from 0 to a rand max of 231-1. The amount of state information used can be modified by calling initState function and is allowed to range from 8 to 256 bytes. However, if fewer than 32 bytes are used, the code backs off to using a linear congruential generator. The generator operates by having two integer pointers into an array of state information. Each time a random number is requested, the corresponding values in the state array are summed. The result of the summation is then stored in the state array, replacing the value pointed to by one of the pointers. This new value is also subsequently used as the random value generated by the algorithm. However, since the new value is a 32-bit integer and only 31 bits are needed in order to get a random number in the desired range, the least significant bit is dropped in order to get the final random value returned by the routine. After generating and storing the new random value, both of the state pointers are incremented so that they point to subsequent locations in the state array. If either pointer reaches the end of the array, it's resetted to point to the beginning of it. As shown on the code, fptr and rptr are pointers to 32-bit integers inside the state array. The pointer result is used to store the random value that will be returned by function. The initial state array is populated with values generated using a linear congruential random number generator. The pointer rptr is initialized to point to the beginning of the state array, while the initial location pointed to by fptr varies according to the size of the state array. For the default state array size of 128 bytes and state 3 is used. Recall that the period of random number generator is the number of random values that it generates before the sequence repeats itself. For this generator, the size of the period will depend on the amount of state information used. According to the Linux man page for random, when using the default of 128 bytes of state information, 16 by 231-1. Let's now look at the Java language. In Java, the class random from the package java.util can be used to generate pseudo-random values for a variety of data types, specifically boolean, byte, int, long, float, and double. For doubles, random values can be generated along both a uniform distribution in range 0, 1 and a Gaussian distribution with mean 0.0 and standard deviation 1.0. For integers, random values are uniformly distributed across all the values that can be represented using a 32-bit signed integer. Internally, all random values generated by objects of this class are produced by calling the method next, that returns an integer with the requested number of random bits. This value is then used to generate the various type-specific random values. The implementation is convenient as it allows subclasses of random to simply replace this method with one that implements an alternative pseudo-random number generator, and then all of the other type-specific methods will generate random values using the new algorithm. To generate random values, next function uses the linear congruential pseudo-random number generator shown on the screen. Note that even though seed is stored as a long Java signed 64-bit integer type, only 48 bits of state information are stored in it. Further, the constant multiplier and increment are identical to those used in the popular RAND48 family of linear congruential random number generators found on many Unix-like systems. Additionally, a library routine from this family of generators, DRAND48, is also Perl's preferred generator on platforms that support it. The given recurrence has a period length of 248. This is order 1014. As such, since the modulus is also 248, the underlying generator can be said to have a full period. Let's now see how Perl implements random numbers. In Perl, real-valued uniformly distributed pseudo-random numbers can be obtained by calling the function rand. This function takes one argument that specifies the upper limit on the range of random values. That is, rand n will return a real-valued random number in the range of 0 to n. This value can then be passed into int function if random integer values are desired. Rather than rounding to the nearest integer, int function just removes the decimal point of its argument. This truncation is actually desirable in this case, since it results in random integer values that are still uniformly distributed in the range of 0 to n. If rounding was performed, 0 would be less probably than all of the other integers in the original range, and the range would change to 0n. Perl generates random numbers using the library routines provided by the platform it has been compiled for. Specifically, Perl's first choice is to use drand48. However, if it's not available, it will try to use random. If both of these are unavailable, it will settle for rand. Perl's configuration script has somewhat amusing commentary on its preferences regarding the tree routines. Let's now look into Python. In Python, random numbers can be generated using the module random. This module not only provides routines for generating uniformly distributed integer and real-valued pseudo-random numbers, but also provides routines for real-valued numbers distributed along a sizable number of different distributions. As an example, beta, exponential, gamma, Gaussian, and Weibull distributions. Additionally, there are routines for shuffling sequences and sampling from a collection. The module is implemented using a hidden object instantiated from the class random.random. The functions in the module simply invoke the corresponding methods in this object. The random class itself is an organization in a manner similar to Java's random class, whereby if you recall, all the methods for generating random values depend on the method next. In Python's case, the core method's name is random, and it generates real valued numbers in the range of 0 to 1.